And in this class, we're going to study electrolysis. And electrolysis are related to electrode potentials. Now, electrolysis is kind of different from what we had studied earlier. What we had studied earlier, earlier we were studying cells. For example, this cell over here. So earlier we were studying cells. Now in cell, there's no external power source. I mean, there's no battery. There's a higher potential electrode, which over here was 1.52 volts, and there's a lower potential electrode, which over here was 0.77 volts. So in an electrochemical cell, there's no external power source. Whatever is driving the electrons, it's the chemical reaction that's happening. There's a higher potential side which likes to gain electrons, so it moves in the forward direction, and there's a lower potential side which likes to lose electrons, and it goes in the backward direction, starts producing electrons. So the electrons are being driven through the circuit by the reactions that are happening over here. One side is gaining electrons, the other side is losing electrons. So it's an electrochemical cell is one that converts a chemical reaction into electrical energy and drives the electrons in the circuit. When we talk about electrolysis, electrolysis does the exact opposite. What it does is that it converts electrical energy. There's an external power source. There's going to be a battery involved, and that electrical energy is going to be converted into a chemical reaction, or it would be converted into chemical energy. So because of an external power source, there's going to be a reaction that's going to happen. Now I'm going to draw the first simplest possible electrolysis that you've already studied in O levels. And in that electrolysis, you have, so in, so now in that electrolysis, you have two electrodes. One is known as the cathode, the other one is known as the anode. So here are two electrodes, and these two electrodes would be connected to each other through a battery. So this is your battery, and there's a positive side and a negative side. This side is the negative side, the smaller terminal. The other side is your positive side. That's your bigger terminal. This side, the battery is sending electrons. So electrons are being sent by the battery on one side, and on the other side, electrons are being taken back. So electrons are being pulled back by the battery. So that's what the battery is doing. One side is positive. Why is it positive? Because the battery has taken away all the electrons. So this side is your positive terminal. And the other side has too many extra electrons because the battery is sending electrons. Now, there's going to be an electrolyte in the solution. The electrolyte, I'm going to pick the simplest one, let's say NaCl molten. Now, in NaCl molten, there's going to be two ions. One is sodium ion. Sodium ions get attracted to the negative electrode, and you have Cl minus one ions which get attracted to the positive electrode. And battery is sending electrons. So electrons would eventually be gained by sodium ions over here. So the reaction that's going to happen over here is that sodium ions would gain electrons to form sodium, and on the other side you have Cl minus one. Battery is pulling electrons. So who's going to lose electrons? It's going to be Cl minus one that would end up losing electrons, and Cl is a diatomic molecule, so it would be 2Cl minus one that would be losing two electrons to form Cl2. So a loss of electrons, or in other words, oxidation would happen at anode. And at cathode, there's going to be a gain of electrons. And reduction is going to take place uh, at cathode. So this is your cathode. This is your anode. There's nothing different. This is all O levels electrolysis. This side is your anode side. So just to recap, there's a battery external power source which is driving the electrons. So one side is the battery is pushing electrons. So anyone that approaches this side is going to be the one that gains electrons. The other side, the positive side, is the anode. The battery is pulling electrons. So anyone who goes over here is going to end up losing electrons because the battery is going to pull electrons from it. So Na plus 1 ends up gaining electrons. Cl minus 1 over here ends up losing electrons. The cathode is the negative, so it always attracts positive ions. The anode is positively charged. It always attracts negative ions. ठीक है सारा, is this clear? Abu Huraira, clear है? Aisha?
Yes, sir.
Yes, sir.
Aisha, so this is simple electrolysis. Now we're going to do a bit more complicated electrolysis, in which I'm going to bring in electrode potentials as well. So the complicated electrolysis is, let's do the electrolysis of copper sulfate, but this time copper sulfate is aqueous. So we're going to try and do the electrolysis of copper sulfate aqueous. I'm going to make the beaker just like before. Okay, so let's say this is my beaker and these are my two electrodes. So these are my two electrodes and they're connected to a battery. So they're connected to a battery and okay, that's fine. So they're connected to a battery. So there's an electrolysis going on. And this side is your cathode, so the battery is sending electrons. This side is the anode, the battery is pulling away electrons. So cathode side, which is going to be your negative side. And anode side, which is going to be our positive side. So two sides. So what's in the electrolyte? Now, if you have copper sulfate aqueous, there's going to be copper 2 plus ions, and copper 2 plus ions would be attracted to the cathode. And there's going to be SO4 2 minus ions, and SO4 2 minus ions would be attracted to anode. But remember, when a substance is aqueous, aqueous state means that water is present. H2O is present. And the difference between O levels and A levels is that in O levels you studied that water molecules, they ionize to produce two ions. One is H plus 1, the other one is OH minus 1 ions. But in A levels you study that the quantity of H plus 1 in a solution is usually very, very less, 1 times 10 per minus 7 mole per decimeter cube. And the concentration of OH ions is also very, very less, almost non-existent. So we're going to assume that the dissociation is almost negligible. There is no dissociation. That's one major assumption, one major difference uh, that you make. Assume that water does not ionize. Because in reality, the amount of H plus 1 and the amount of OH ions that are being produced because of that ionization, the ions are so few that they would hardly matter. So water molecules are going to be taken as water molecules. They're not going to be taken as H plus 1 or OH ions. And water is a neutral molecule. So that means water would be present at cathode because it's neutral. So it means that water molecules are going to be present at cathode. We move this. And they would also be present at the anode. So they're going to be at both places at the same time because they're neutral. So, and because the whole solution is aqueous, which means that they are everywhere in the solution. So they're at cathode, they're at anode as well. And your task now is you need to figure out who's going to gain electrons at cathode. The electrons are coming in. So these are the electrons that are coming in. So who's going to gain electrons? Whether the electrons are going to go to copper 2 plus or whether they're going to be gained by water molecules. So that's the question. So two things: copper 2 plus or H2O. You have two species. Who gains electrons? Now, based on what you have
2
studied,
plus.
hmm?
Cu2 plus.
ठीक है, Cu2 plus. लेकिन किस तरह? How did you figure it out? You figured it out by looking at the electrode potentials. You figure out who gains electrons, uh, higher potential. ठीक है, we have electrode potential, higher potential, a higher electrode potential. The one that has the higher electrode potential is the one, or simply higher potential, has a greater tendency to gain electrons. So likes to gain electrons. So what you're going to do is you're going to look in the data booklet and find copper 2 plus and water molecules, and you're going to code those equations where they're gaining electrons. So look for equations in the forward direction. In the forward direction. What that means is that over here, like previously, I mean, there is no choice. I mean, they have to gain electrons because the battery is sending electrons. So the reaction would always be going in the forward direction. So it's either copper 2 plus or H2O. So I'm going to write down all the electrode reactions where you have copper 2 plus and H2O, and they're trying to gain electrons. So I'm going to open the data booklet, and you can see copper over here. So this is the one where I have the cursor. It's copper 2 plus, trying to gain 2 electrons. So I'm going to write this equation in the forward direction. I'm not going to write a reversible sign because there is no choice. They have to gain electrons. So it's copper 2 plus gaining 2 electrons, and the value is 0.34 volts. So then there's another equation where copper 2 plus is gaining right below that. There's another equation where copper 2 plus is gaining just 1 electron. So you have copper 2 plus gaining 1 electron, and it's forming copper 1 plus. And this value is 0.15 volts. So I've copied both of these reactions. So I have two equations in the data booklet where copper 2 plus would be gaining electrons. The battery is sending electrons, so copper 2 plus would be gaining electrons. Now there's another thing which is water. Water might be gaining electrons as well. So I'm going to open the data booklet and I'm going to try and find water. So if you look over here, there's this equation, and this equation would also be written in the forward direction. So there's another reaction where two water molecules are gaining 2 electrons to form. What are they forming? They're forming hydrogen and 2 OH ions. And the value for that is minus 0.83 volts. And there's no other equation of water gaining electrons. So I've written that down as well. So I have three options. Who's going to gain electrons? Either copper 2 plus or H2O. Two equations for copper 2 plus, one for water. And what's the rule? Who ends up gaining electrons? It's always the higher E naught that likes to gain electrons. So the highest E naught out of all the three is going to be this one, which means that this is going to be the reaction that would be happening. This is the highest probability reaction that would be happening because it has the highest potential and it has the greatest tendency to actually gain electrons. ठीक है, is this clear? Aisha, is this clear? Burera, Sara?
Yes, sir.
Yes, sir.
Yeah, sir.
Acha, on the other hand, you have, ठीक है, okay, is this clear? Acha, on the other hand, you have दूसरी साइड पे आ जाते हैं एनोड पे. Now at anode, you want to figure out who ends up losing electrons. ठीक है, anode पे there's going to be loss of electrons. So you need to figure out whether it's water that ends up losing electrons to the battery or it's SO4 2 minus that actually ends up losing electrons. So you need to figure this out. So I'm going to write this down, that who loses electrons, whether it's SO4 minus 2 or H2O. So who's going to be the one that's going to lose electrons? And based on our electrode potential understanding, it's always the lower potential, the one with the lower E naught. Lower E naught likes to lose electrons. So I'm going to look in the data booklet and I'm going to look for equations where they are. So look for equations in the backward direction, because that's the direction in which they lose electrons. Okay, so I'm going to pick water first, and I'm going to find water. Okay, in the data booklet, forward is gaining electrons, backward is losing electrons. So I need to find equations for water. So if you look over here, this one. If you look at this equation in the backward direction, then water molecules are losing electrons to form H2O2, H plus 1 and 2 electrons. So this is one equation which I'm going to copy. So it's, but I'm going to write this in the backward direction. So it's going to be two water molecules. They would end up losing 2 electrons plus 2 H plus 1 ions plus what else? H2O2 is going to be produced, and the value for that is 1.77 volts. And right below that, there's another water equation. This one over here. If you look at it, this equation in the backward direction, again, it's losing electrons. So it's two water molecules that would end up losing in the backward direction. They would lose 4 electrons plus 4 H plus 1 ions would be produced plus O2 is going to be produced. And the value for that is 1.23 volts. So I've copied both these reactions, but in the backward direction. Okay, so because I'm looking for equations where they lose electrons. And then there's SO4 minus 2. So I need to find SO4 minus 2. It might also lose electrons. So over here, there's SO4 minus 2 over here. And if you look at this equation in the backward direction, it loses electrons. So this equation is 2SO4 minus 2. It would end up losing electrons to form S2O8 2 minus plus 2 electrons, and the value is 2.01 volts. Okay, that's the value. So I've written that down as well. Now, in the actual paper, you don't have to waste time writing these equations, because these equations would be written in the data booklet. You would just mark them over here, and you're going to select the right one. So who loses electrons? Or who likes to lose electrons? So the rule is the lower potential one is the one that likes to actually lose electrons. So out of these three, which one has the lowest potential? It's this one. So it's going to be water that would be losing electrons to form 4 electrons plus 4H plus 1 plus O2. So this is the reaction that would happen at anode. The thing is, you don't have to write all these equations. You can mark them on the data booklet. Also, these equations, you can mark them on the data booklet. Remember, at cathode, you're looking for the higher potential one, and at anode, you're looking for the lower potential one. Is this clear? Yes or no? Is this clear? Aisha, clear?
Yes.
Okay.
Yes.
Yeah, sir.
Acha, so let's Let's do another question. Okay, this time I have, let's think of electrolysis of NABR aqueous. And let's see what's going to happen. Okay, so quickly drawing the diagram, the two electrodes. Okay, and they're connected to a battery. So that's your battery. Now NABR aqueous. NABR is Na plus 1 ions at cathode and Br minus 1 ions at anode. So this is your cathode. And remember, I'm talking about inert electrodes right now, which are made out of platinum or graphite. So battery is sending electrons. Over here, battery is at anode, battery is losing it's pulling electrons away from them. So what other things would be present? Water molecules would be present. Both sides. So we need to figure out who gains electrons, whether it's Na plus 1 or whether it's H2O. And over here, I need to figure out who loses electrons. So whether it's H2O that ends up losing electrons or whether it's Br minus 1. So I'm going to start off at cathode. And at cathode, you have two options. One is Na plus 1. The other one is H2O. So I'm going to open the data booklet. I'm going to look for equations in the forward direction where they're gaining electrons, because at cathode, always reduction happens. By definition, cathode is the place where reduction takes place. I mean, they're going to gain electrons, battery sending electrons. So I'm going to open the data booklet and find Na plus 1. It's right over here. So Na plus 1 gaining electrons. 1 electron. I'm going to write this in the forward direction. And it's forming Na. And the value is minus 2.71 volts. The other one is I need to find water gaining electrons. So it's the same water equation which we found earlier. So there's this equation over here where two water molecules are gaining 2 electrons, and the two water molecules are forming H2 and 2 OH ions. And the value I have is minus 0.83 volts. So I've written down the two reactions. And who gains electrons? It's always the highest E naught that likes to gain electrons. And out of these two, the highest E naught is this one, minus 0.83 volts. So that's the one that ends up gaining electrons. And on the other side, at anode, there's going to be, so at anode, you're going to have oxidation, loss of electrons. You have two substances, Br minus 1 or H2O. Someone out of these two would be the one. So it's either Br minus 1 or H2O. Out of these two, you need to figure out who loses electrons. So I'm going to look for equations where Br minus 1 and H2O lose electrons. So Br is in B. The equation must be in backward direction. So you have 2 Br minus 1. And it loses electrons to form Br2 plus. 2 electrons, and the value is 1.07 volts. The other one is for water. Water might lose electrons as well. So it's the same two equations, one over here. So it's 2H2O. And it loses electrons to form O2 plus 4H plus 1. Plus it's O2 plus 4H plus 1 plus 4 electrons. And the value is 1.23 volts. And the other one is right above that. So it's again two water molecules. that lose electrons to form H2O2 plus 2H plus 1 plus 2 electrons. And this value is 1.77 volts. So coming back, I've written the three reactions. Br minus 1 and H2 are losing electrons, and the electrode potential values are also written over here. So I've written them. And who loses electrons? It's always the lowest potential, the lowest E naught, that always ends up losing electrons. So which one is the lowest E naught? In this case, it's the Br minus 1 equation. So that's the reaction that would be happening over here. Okay. Aisha, is this clear? Sarah, Abu Rera, is this clear?
Yes, sir.
Yes.
I said then the next thing I'm going to bring in is that we studied, and this only applies to a particular electrolysis. We studied that changing concentration. So remember, changing concentration changes the electrode potential. Okay, all your electrode potentials, they're calculated under standard conditions. And we're going to focus on this one. Two Cl minus 1, and the E naught value is 1.36 volts. Now remember about this reaction that if you increase the concentration of Cl ions, okay, so if you increase Cl ion concentration, okay, square bracket says concentration, the equilibrium would try to decrease it, and it's going to shift the equilibrium in the backward direction. And if it does that, if it shifts equilibrium in the backward direction, more electrons are going to be produced and your potential would become lower. So if you increase Cl ion concentration, equilibrium shifts to the left. And as it shifts to the left, more electrons are produced on the electrode, and your electrode becomes, the potential becomes less than 1.36 volts. It becomes more negative. So let's assume example is that it becomes 1.20 volts. Okay, the potential drops. So remember about Cl minus 1. This applies to all other reactions as well. That according to the De Chatelet principle, this equilibrium is going to shift if you change conditions. So if you change conditions and the equilibrium shifts in the backward direction, the potential drops. The reason we are discussing chlorine only is because chlorine's potential is very close to water's potential. Okay, whenever there's aqueous, there's water present, and water's potential is 1.23 volts. Chlorine's is 1.36 volts. So usually you're going to have confusions between chlorine and water molecules. We're going to do one example, which is that we're trying to electrolyze KCl aqueous, but it's concentrated. So if you try to do the electrolysis, here are your two electrodes. So that's your battery. I said, that's your battery. I said, now if you try to do this electrolysis, KCl aqueous means there's going to be K plus 1 and there's going to be Cl minus 1. and on both sides they're going to be water molecules. Here they're going to try and gain electrons, either water molecules or K plus 1. And here the battery is pulling electrons, so they're going to try and lose electrons. So it's either water molecules that end up losing electrons, or it's going to be Cl minus 1 that ends up losing electrons. So we need to figure that out. So we're going to try and do just that. I'm going to write down the reactions. So it's K plus 1 plus 1 electron, and it forms potassium. Here they're gaining electrons. So I'm going to write the equations in the forward direction. You can find K on your own. Here's K plus 1 gaining electrons to form K, and it's minus 2.92 volts. And then you have water gaining electrons, so you can find that equation, water gaining 2 electrons to form H2. We can copy the equation from the top. Okay, we can, instead of looking in the data booklet, it's 2 water molecules gaining 2 electrons to form H2 and 2 OH ions, and its potential is minus 0.83 volts. So minus 0.83 volts. Now, here there's no confusion. The potential differences are, there's a huge difference between the potential difference. So who gains electrons? It's going to be the highest E naught that gains electrons, which in this case is not this one. It's going to be the water equation. Okay, so no confusion there. But on the other side, who loses electrons? Okay, the equations must be found in the backward direction. So for chlorine, it's going to be, so for chlorine, it's going to be this one in the backward direction. Cl minus 1 losing electrons to form Cl2, and the value is 1.36 volts. So for chlorine, it's 2Cl minus 1 losing electrons to form Cl2, and the value is 1.36 volts. The other one is water. So I'm just going to copy the water equation from the top. The equations are 2 water molecules would lose electrons to form O2 plus 4H plus 1 plus how many electrons? 4 electrons. And the value is 1.23 volts. The other one is 2 water molecules are losing electrons to form H2O2, 2H plus 1 plus 2 electrons, and the value is 1.77 volts. So I've copied both those equations from the top. Now, what was the rule? Who loses electrons? So it's always the lowest potential that loses electrons, which in this case is this one, right? It should be this one. But remember that what we just discussed, that if Cl minus 1 is concentrated, we can add this over here. So if Cl ions are concentrated, we had discussed what would happen to the potential value. If Cl ions are concentrated, this equilibrium would shift to the backward side and more electrons are going to be produced, and the potential would decrease. It would become lower. It would become more negative. So it's going to be less than 1.36 volts. And I gave an example that it would become 1.2 volts. So if KCl is concentrated, that means Cl ions are concentrated. So your potential, instead of being 1.36 volts, it would be actually much lower. It would be 1.20 volts. Let's assume it decreases. Okay, Aisha, is this clear? Abu Rera? Sara, is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so if you now look for the lowest potential equation, then it's not going to be 1.23 volts. It's actually going to be this one. And it's not going to be this one. So because you have changed conditions and you've made Cl minus 1 concentrated, the potential of Cl minus 1 dropped. And we know that who loses electrons, it's always the lowest E naught that has the greatest tendency to actually lose electrons. And because of the changes in conditions, the potential changed, and Cl minus 1 actually became the lower potential equation. So remember this: if Cl minus 1 is concentrated, then that means its potential decreases, and if it becomes lesser than the water potential, so if it becomes lesser than the water potential, then Cl minus 1 would be discharged. And Cl2 gas is going to be produced. So Cl2 gas is going to be produced. So this is what happens. Otherwise, you were getting oxygen gas in normal conditions. If KCl wasn't concentrated, if KCl was just normal KCl, then you would be getting oxygen gas. But now, if Cl is concentrated, then it becomes the lower potential equation, and it instead gets discharged. Okay. So is this example clear? Remember, for Cl minus 1, it's going to be the concentration would matter. It's not going to matter in other cases because the difference in potentials is going to be huge. Okay. For example, Br minus 1, it doesn't really matter because even if you make it more concentrated, the potential is still is. I mean, you've already selected it, so it doesn't really matter in this case. So in most cases, changing concentration would not matter, but in the case of chlorine, it's going to matter because its potential is very close to water's potential, and if its potential changes, then you're going to select this equation instead of this equation. Okay? Sara, clear hai? Aisha, is this clear? Abu Rera?
Yes, sir.
Yes, sir.
Yes, sir.
चलें ठीक है. Chelsea, we'll continue with this फिर next class में. ठीक है? We've done electrolysis. Past papers करेंगे इसके. ठीक है? Okay then.
Okay, sir. Allah Hafiz.
Allah Hafiz.
Love is